Okay, so number 4 diverges and number 5 converges. And once again, on a quiz or test, especially on number 5, I would be looking to see that the value of that integral equaled 1/2. So therefore, the series converges. The series does not converge to 1/2. It's going to converge to a number that's actually bigger than 1/2, but we're not going to be concerned about that. All right, the good news about p-series is that there's a pattern to the p-series. And from here on out, all you have to do is identify what p is and remember the properties of p-series to determine whether it converges or diverges. So if p is greater than 1, your series will converge, and if p is between 0 and 1, it will diverge. So 1 over n to the 3/4. What is your value of p? 3/4. So does the series converge or diverge? Okay. 3/4 is less than or equal to 1, so therefore the series diverges. So if you will just identify that it's a p-series and identify what p is, then you can immediately go to it diverges or it converges. P-series is 1 over n to a power, and then you're looking at whether the power is greater than 1 for it to converge or 0 to 1 for it to diverge. What you're focusing on is 1 over n to a power for it to be a p-series. It could start at n equal, it can't start at n equals 0 because that would give you 0 in the denominator, but you could start with n equals 2. We're not concerned with what it converges to. What the sum of the actual series is just that it will converge. All right, so 1 over n to the 1 plus 2. What is your p-value? So p equals 1.2, which is greater than 1, so therefore it's a convergent p-series. So that's probably the best way to write it. Identify your p and then say it's either a convergent or a divergent p-series. All right, 1 over n. In that case, your p-value is 1. So is a divergent p-series. And what's the special name for the series 1 over n? Harmonic, okay? And actually, if you will just start identifying it as harmonic, you're going to see it a whole bunch. If you'll just start identifying it as harmonic, it's just pretty much accepted that it's a known fact that harmonic series diverge. And so if you just say, oh, that's the harmonic series, so therefore it diverges, then you're good to go. They'll take that on the AP test. Other than a geometric series, you're not going to have to find exactly what it converges to, but later on in the chapter, we're going to be able to estimate a range of values that it would converge to. All right, number 9 is the last problem, and the problem is that it's not written in the summation form. So I need to take the series and write it in the summation form. So it's obviously 1 over something. What's the pattern here? 1 over n cubed. Good. Where n is 1, 2, 3, 4, 5, etc. 1 over 2 cubed, 1 over 3 cubed, 1 over 4 cubed. All right, so that is a p-series. What is your p-value? So converge or diverge? Converge. So from here on out, anytime you see a p-series, you can identify that it's a p-series and tell me whether it converges or diverges by whatever that value of p is. Now, something that's more complicated, like 1, 2, and 3 on the notes, you're going to have to use the integral test to do that. One other comment about the p-series, and that is that the conditions for converging or diverging are exactly opposite of the geometric series. For R in geometric series, it converged if R was less than 1 and diverged if R was greater than 1. So try not to get those confused. If you think about it, though, it makes sense that it will converge if P is greater than 1 because yesterday we talked about a series converging if it approaches 0 faster than some other series. So the bigger the exponent on your bottom, the faster it's going to approach 0, and the more likely it is to converge. So that's why your p-value needs to be greater than 1.